two isotopes of chlorine, and two isotopes of chlorine are 35 and Cl37. So using these isotopes, how many different relative molecular masses are possible for the compound of C2H3Cl3? Now, the question is about how many molecular masses are possible for this type of compound molecular formula, right? C2H3Cl3. Now, how does it look like? Let me just draw it. So you got two carbons, and you got two. How many hydrogens are there? Yeah, you got three hydrogens, and you got three chlorines. So these are the three chlorines: Cl, Cl, and Cl. And these are typical hydrogen molecules. Sorry, hydrogen atoms. Now that's how the compound looks like: C2H3Cl3. Now, what are the possible combinations of this different combinations of this molecular formula? So this could be, this could be Cl of 35. This could be Cl of 35, and this could be Cl of 35. Also, so that's the one option, right? Also, we can replace one of them with the top of them with 37. All right, so 137, and the bottom ones are, that's 2 chlorine with 35. So that's the second combination. And also we can have two of them as 37 and only one of them as 35. So that's the third combination. Or the final combination is you can have all three of them as 37. That's the fourth combination, right? So you can get all of them 35, you can get one 37 and two of them as 35, right? Or you can get one of them as 35 and two of them as 37, or you can get all of them as 37, right? And what else we can think of, like having two of them as, so if I just keep it like one is 35, other is 35, and the last one is 37. That's the second option. We already did that. So I think there are 4 possible combinations we can make out of it.